keep this heart running and pumping, it requires ATP, a lot of ATP. Your heart starts when you're about 7-8 weeks old in your mom's womb. And when it stops, you stop. There's no ifs, ands, or buts about that one right there. So it's constantly, steadily working. And so it has to make a lot of ATP. When you make ATP, it requires a lot of oxygen. It needs a lot of oxygen and such to do that. It'll even store oxygen in the myoglobin and all, which is a molecule which uses extra, helps it store extra oxygen. It'll even make creatine phosphate to help it make ATP in stressful times and such. And if you really work that heart, it'll go anaerobic for a short period of time and make lactic acid. In your normal skeletal muscles, you know how that makes them feel. They hurt, they ache. The heart muscles can actually take that lactic acid and such and utilize that as well. So it's going to make ATP as best that it can. You can check the heart by looking at the ECG, EKG, what do you want to call it? And here we look and you'll see that there is, what you're measuring is actually the contraction, the systole, the contraction as such. You'll get an atrial systole and you'll get a ventricular systole. The atrial will contract at the same time. The ventricles will contract at the same time. So when the ventricles are contracting, the atria are relaxing. So the contraction is known as the systole and relaxation is diastole. So your heart, when you're sitting there, you're beating about 75 beats per minute, and each little thump thump lasts about 0.8 of a second. What's involved in that 0.8? For half of it, your ventricles and your atria are relaxed. And then for about 0.1 of a second, your atria will contract. And then about 0.3 of a second, your ventricles will contract, and then everybody's relaxed again. So about 0.8 of a second. If you go from 75 to 150 beats per minute, that atrial contraction speed stays the same. The ventricular contraction speed stays the same. The only thing that changes is the relaxation time. So that becomes shorter and shorter. So everybody's relaxed. All 4 chambers are doing nothing. Blood is still moving because blood follows its high pressure to low pressure. So the heart's relaxed and blood is moving into the atria, both the right atria and the left atria. All 4 valves, the AV valves and the semilunar valves, are closed and such. So that's a period that you have this all 4 valves being closed. That's osmovolumetric relaxation and all. So no blood is moving into the ventricles and all, but blood is moving into the atria, As the blood fills in, as it moves into the atria and such, the pressure starts to increase a little bit, and then the AV valves just open like a trap door. And that blood then falls from the atria down into the ventricles. So a big portion of the blood that moves into the ventricles is just due to gravity. That's this ventricular filling period. Then you get the trigger, and the atria will contract, and any excess fluid or any extra fluid in there gets pushed into the ventricles. On an ECG, you see that as the P wave. The P wave is due to atrial depolarization. That's what causes the needle on the graph to move. What's happening in the heart? Atrial systole. So it contracts. It causes the pressure of the fluid to increase and pushes it from the atria down to the ventricle and such. And then it's over with. And then each ventricle contains about 130 mils of blood. I think that's collectively both of them together. Of that, only 25 was due to the ventricles moving it, pushing the blood in. So there was already blood in there. Now, some of that was, the big chunk of that blood filling in was from gravity. But some was left. About 60-something was left and all. So when the ventricles contract, you'll notice they only eject about 70 mils. So take 130, subtract 70, 60. 60 is left behind. So now the ventricles contract, and on the ECG, you get that QRS complex. The line goes up, that's the depolarization. The line goes down, that's the repolarization. Then it comes back up and such. And then it's there for a minute, and you get a little bump, and that is the refractory. That's the T wave and such. But that QRS complex is the ventricular systole. And it is stretched out because of that plateau, because you have the depolarization, then there's a moment, and then there's the repolarization as such. So when those ventricles contract, the fluid, which can't be compressed, it's starting to be squeezed, it's not compressed, and the pressure builds up, and it has to leave and such. And the AV valves won't allow it to go back into the atria, so it must pass out through the semilunar valves and such. So the ventricle contraction starts, ejects that blood, and then it ends. And when it ends, the blood in the pulmonary trunk and in the aorta tries to fall back, and then it hits those valves and they slap shut. So, but the ventricular contraction ends, the semilunar valves close, you hear that dub, and then you should notice a T wave on the ECG. When those contract, at the end of it, each ventricle collectively should have about, the heart itself total should have about 60 mils of blood left in it. So your stroke volume is about 70 mils when you think about it. I kind of mentioned those sounds to you. Listening to that, you take a stethoscope, you put it in different areas. Your lab book shows you where to put those, so you can hear each individual valve. But when the ventricles contract and the AV valves close, that's the first sound, lub. And then when the ventricles relax and the semilunar valves, the SL valves close, that's the second sound, dub. So lub dub is the sound that a normal heart will make. Any other sounds you hear, those would be associated with a murmur. And then you take your stethoscope and you put it in the different areas, and you can listen to the particular valve, and you can narrow down where the murmur is. When the valves don't work correctly, then the pump doesn't work correctly, and then you have an insufficiency in there. And that could be the valves problems. There are all myriad of problems there with valves that can happen, and also okie doke. There we go. You're through with the heart.